At the same time as the towers were being built in the middle of the Øresund Strait, the double-decked spans were being assembled at shore. They were immense steel and concrete boxes, about 140 meters long and 23 meters wide. The top would be a 4-lane highway, while the trains would go inside. The designers decided to put the train tracks in a special cement trough. If a train was to derail, they hoped this liner would keep the train on the bridge. The bottom of the spans may look solid, but like the towers, they're hollow. And they too housed equipment critical to the bridge. The bridge contained a total of 80 million kilograms of steel, and steel has a mortal enemy: rust. Rust could potentially destroy the bridge from the inside out. Paint can add protection, but it was not economical to paint so much surface area. So instead, the Øresund Bridge was constructed to contain a vast system of dehumidifiers. These keep the air inside below 60% relative humidity, and no moisture means no rust. Regulations required crews to inspect every part of the bridge. This was obviously a prudent measure, but a big challenge, because the underbelly of the bridge was 60 meters above water. Even on the road, workers had to be protected without interrupting car and train traffic. Luckily, the Øresund engineers had planned ahead. Hanging under the bridge is a spectacular motorized gantry. The Øresund link has one of the few gantries in the world that can run the entire length of the bridge. Most gantries would be stopped at the bridge towers. But this gantry pivots to squeeze between the supports. On the other side of the tower, it spins again and continues on its way. Once the crew is in the right place, the Øresund's gantry works like a gigantic Swiss Army knife, packed with exotic contraptions. A hydraulic arm can carry a worker outside the trusses, up and over the roadway. The access is phenomenal and, most importantly, doesn't interrupt the flow of train and car traffic. Hanging so far above the water, the arm gives access to equipment like this device, created especially for the Øresund Bridge. It's a damper to reduce cable vibrations that could potentially shorten the life of a bridge by decades. The gantry has another gadget used to inspect the towers. This hanging bucket can lower workers 60 meters, right down to the waterline, where they can check the concrete for cracks and even change the light bulbs that guide ships through the navigation channels. From the gantry, it's easy to see that the deck was assembled from pieces. It's less obvious how the pieces got here. The enormous segments were pre-assembled several kilometers away on shore. The good news was that they only weighed 5.5 million kilograms, not 18 million like the foundations, or 55 million like the tunnel elements. The bad news was that the tunnel and foundations were lowered into place. The bridge spans needed to be lifted, 60 meters up, and then held, dangling in the air. By any measure, the Øresund link was one of the most ambitious engineering projects of the 20th century. The contractors built from scratch an artificial island 9 kilometers around. They ground through 4 kilometers of ultra-hard Copenhagen limestone. And they pieced together the world's largest submerged tunnel. Now, with just 1 year left, it was time to begin the last and most spectacular stage of construction. Finally, the bridge would start looking like a bridge. All the planning and all the calculations would be put to the test as the main span was put into place. It had to be high enough for ships to pass under and strong enough to carry speeding trains and cars. No one had ever built a bridge like it. What was required was the largest floating crane on Earth, capable of lifting more than 7 million kilograms, the equivalent of 30 Boeing 737s. It was called the Swan, and this was her moment of glory. The Swan had to use 75% of her total strength to lift each span. The highest span went right next to the tower. Then crews attached cables. The first cable was 50 meters long, and each new cable would be longer than the one before it. The longest would be over 260 meters. The Swan brought in another span. The roadway cantilevered further from the tower and closer to a world-size record. This was the most vulnerable time for the bridge. Temporary scaffolding helped, but the bridge wouldn't be up to full strength until all the pieces were in place. Wind and storms could be disastrous. On the 14th of August 1999, the Swan installed the final roadway span on the bridge. Denmark and Sweden were connected for the first time. Denmark's Prince Frederik and Sweden's Crown Princess Victoria met at their first ever border crossing. For 9 years, the construction deadline had loomed over everything and everyone involved in creating the Øresund link. Finally, on the 1st at 11 p.m., the Øresund link officially opened for business, on time and on budget. The bridge may have been open, but the challenges didn't stop there. Now it had to pay back every penny spent on it, one toll at a time. The official budget for the bridge, tunnel and island was close to $3 billion, and the expenses would never stop. There will always be maintenance. Not long after the link opened, engineers discovered a problem with the guardrails. The bolts were corroding. One bolt was not much of a problem, but there were 16,000 of them, and if they failed, a minor fender bender could turn into a death plunge. Crews had to act quickly to prevent the bolts from rusting through. It was a big job, but it was better than waiting now and having to replace the bolts later. That would have required tearing up the concrete. Stopping the corrosion started with removing the nuts and blasting the bolts clean. To keep out moisture, crews coated the bolts with gel and used better fitting washers. Maintenance and everything else that happens on the bridge is monitored in Sweden from a building near the toll plaza. Hidden inside is a high-tech command center.
Traffic center, Arne. Okay. He's coming to work.
from the bridge feed into the control room computers. Operators constantly monitor safety. Operators to monitor, so a computer helps. It's able to recognize stopped cars and cars going the wrong way. Operators constantly monitor safety. There are 256 cameras on the link, too many for operators to monitor, so a computer helps. It's able to recognize stopped cars and cars going the wrong way. When it spots trouble, it alerts the operators and shows them the appropriate camera. Operators can also manually control the cameras, which have incredible zooms. One of the Øresund link's pleasant surprises can't be seen from the control room. It's underwater. The 51 bridge piers have had an unexpected environmental impact. They've become artificial reefs, covered in mussels and plants, providing food and shelter for sea creatures. Environmentally, here. Creating a fixed link across 16 kilometers of the Øresund Strait had been a dream for generations. It was a monumental engineering effort, pushing technology to the absolute limit and establishing new world records, from the coast of Denmark to the coast of Sweden. The largest submerged concrete tunnel in the world. The world's longest double-decked bridge for car and rail traffic. And the tallest freestanding double-leg pylons on any bridge anywhere in the world. In its going to new jobs, to new homes, or just exploring. The Øresund link changed the map of Europe, successfully bringing two cities, two countries, and an entire continent closer together. It stands as one of the world's mega bridges.